In this video, we want to work on number of regions, like this problem of AIME that we have here. I will tell you how to calculate number of regions when we have lines, when we have zigzags, when we have angles, when we have circles, ellipses, for different shapes, because it's a famous problem and it has an idea. A famous idea you should know, and then you can solve all problems, and after working on the idea, we will solve this AIME 2 2022 easily. Okay, so let's start. Let me write a problem. Suppose there are n lines, and we want to see what's the maximum number of regions. There are n lines, and the problem is what's the maximum number of regions. So when you want to solve this, let's try with, for example, one line, two lines, and then draw lines step by step. What's the maximum number of regions? So the idea is what? To draw the lines one by one. For example, I draw first one line. How many regions are there? Two regions, okay? Now, if I draw next one, how many regions are there? Four. It will be plus two. As you can see, we have one intersection, and this line passes through here and here. They were one region, but when it passes through them, it divides, it split each of them into two regions, so it adds one for each of them. Now, it will be 2 plus 2. Then, if we consider third line, as you can see, it has two intersections. So it passes through how many regions? 1, 2, 3. So it adds 1 because of passing. When it passes through a region, it divides that region to two parts. So it adds 1 because it was 1, now they are here. We have two regions. So 1 changes to 2. So plus 1 for each region. Plus 1, plus 1, plus 1, plus 3. Okay, so it will be plus 3. Now let's consider, we want to see, okay, the next one, how many regions? And now I want to see nth line. So it was 2 is for second line, 3 is for third line, and now we want to consider nth line. If we consider nth line, it intersects previous lines, each of them in at most 1 point. So how many intersections? So we should pay attention to intersections. How many intersections are there here at most? If we consider, it will be n minus 1 at most. So it passes through how many regions? 1, 2, here look, before 2, 2, before this n minus 1 and n regions. So region 1, region 2, region n minus 1, and region 1. So nth line will be added by, the effect of nth line is n. So the number of regions will be 2 plus 2 plus 3, 4 to n. We can write these two as 1 plus 1. And you should know the formula for 1, 2, 3. There are around 4, 5 important identities. You should know them. It is n times n plus 1 over 2. So here you have 1, and 1 plus 2 plus 3 to n is n times n plus 1. So n times n plus 1 over 2, the number of regions. Let's check it. For example, for 3 lines, we have 1, 2, 3, 4, 5, 6, 7 regions. If we replace n with 3, it's 3 times 4, 12 over 2, 6 plus 1, 7. Okay. So the idea was this. Now, if we solve, instead of, for example, n lines, we solve previous problem for n, for example, angles. Here, you should consider if you have two angles, what happens? What's the maximum number of intersections? You can see the maximum number of intersections equal to 1, 2, 3, 4. And now, when you want to draw, you want to see, okay, nth angle, what's the effect of nth angle? So you should see how many intersections are there, like line, on nth angle. So you say it intersects each of previous angles in 4 points. So it will be 1, 2, 3 to 4 times n minus 1. Okay. Now let's write. When we have one angle, we have two regions. Okay. The outside of that angle, inside. When we draw next angle, second angle, we have 4 times 2 minus 1 intersections, so it passes through how many regions? If we calculate 1 region, 2 regions, 3 regions, to 4 times n minus 1 plus 1. Okay, so for second line, for second angle, it will be 4 times 2 minus 1, 4 times 1 plus 1. For third angle, it will be 4 times 2 plus 1. And for nth angle, it will be 4 times n minus 1 plus 1. Now, if we want to calculate, we have how many ones are there? It is for nth angle. How many ones are there from 2 to n minus 1? So we have 2 plus n minus 1. This 2 is because of this n minus 1 ones. And then we factor from 4. It will be 1, 2 to n minus 1. In previous page, I told you that 1 to n, memorize this one. So much useful. N times n plus 1 over 2. So here is n minus 1 times n over 2. So it will be n minus 1 plus 2 is n plus 1. You multiply 4 by this. It will be 2 times n minus 1. So it will be 2n squared minus 2n plus n. It will be 2n squared minus n plus 1. Let's check. If you replace n with 1, it will be 2 minus 1. 1 plus 1, 2. If you consider two angles, it will be 1, 2, 3, 4, 5, 6, 7. So if you replace n with 2, it will be 2 times 4, 8 minus 2, 6 plus 1, 7. So it works. Okay, always check at the end. Now these things were, so look at step by step. We draw first one, second one, third one. Sometimes we have what? We have some shapes that are closed shapes. Angles, look, they go to infinity. Lines go to infinity. But some shapes like, for example, circles. They are closed shapes. Okay, let me make it thicker. Okay, they are closed shapes. So we want to solve previous problem. Here, 4 shapes. Next problem. Previous problem, 4 circles. So we have n circles. We want to see what's the maximum number of regions. Okay, so let's see. Again, we draw the circles one by one. So when we have one circle, so the idea is draw one by one. Okay, the most important idea here, draw one by one. So the first circle, how many regions are there? 1, 2. Now let's draw second circle. How many intersections are there? 2. But when we have 2 intersections, it passes through 2 regions, so it adds 2. Why in previous one, in angles and line, when we have, for example, some number of intersections, we have plus 1 regions, like lines. For example, n minus 1 intersections, n minus 1 plus 1 regions. But in circles, it is equal to number of intersections. We have 2 intersections and 2 regions. It passes through the region. The reason is because circle is a closed shape. Okay. So it passes through 2, so we add 2. Now if we consider third circle. Let me draw third circle with another color. How many intersections are there? 1, 2, 3, 4. So it passes through 4, 4. Now let's consider nth circle. If we consider nth circle, can you tell me first how many intersections are there? What's the maximum number of intersections on this circle? It passes each of previous circle in 2 points. Pause the video and try by yourself first. 1, 2. But how many circles are there? N minus 1. So 2 times n minus 1. So it will be, for example, the next one 4, the next one 6, plus 2 times n minus 1. Now, if we calculate, we ignore the first 2. From second to, means we don't calculate. We write first 2, then for next one, it will be 1 plus, if we factor from 2, it will be 1 to n minus 1. And if we calculate, It will be 2. This part is n minus 1 times n over 2. 2 will be cancelled. And if I write, it will be n minus 1 times n over 2. And it is equal to these two. These two will be cancelled. It is equal to 2 plus n times n minus 1. Let's check. If you have one circle, 1 times 0, 0 plus 2. If you have two circles, 2 times 1, 2 plus 2, 4. If you have three circles, 1, 2, 3, 4, 5, 6, 7, 8. If we check 3 times 2, 6 plus 2, 8. So for circles, we solved. Now let's solve the problem. As homework, so I write some homeworks and then we will work on AIME problem. Try to solve for n, let me tell you, exactly previous problem for n ovals, B for n zigzags. Zigzags, I mean this. You can solve for some this one, this one, this one. These two lines go to infinity. Okay. Now n ovals and zigzags and angles we solve. N, for example, squares. The n triangles. Also, you can solve, for example, E for n circles and, for example, m lines. You can use any combination of these things. Okay. Now let me tell you a hard part. It is hard. N planes in the space. What's the maximum number of regions that n planes can create in the space? It is harder than previous ones, but we can solve exactly like previous part. The idea is same, but the problem solving that is needed for this part is a little harder. Okay, so, and if you had question about these parts, any of these parts, as I said before, feel free to send message to my WhatsApp number in the description comments. Okay. Now let's solve AIME problem. Let's go back. Our AIME problem. Here, let's read the problem and see it is what. It says let LA, LB be two distinct parallel lines, LA, LB, for positive integer m and n, distinct points A1, A2, A3 to AM, lie on AL. Okay, so in general, we have up to AM. And distinct points B1, B2, B3 to Bn, okay, we have on LB. Additionally, when segments AI, BJ are drawn for all I from 1 to m and j from 1 to n, no point strictly between LA and LB lies on more than two of the segments. It means what? For example, it says that when we draw the lines, we don't have, for example, another line. But for example, it intersects. Let me write with other color. We don't have concurrent line. Concurrent means what? We don't have three lines that passes through a point, a common point inside between these two lines. Okay. And then the next one, it's the reason it says this because to maximize number of regions. Then it says find the number of bounded regions into which this figure divides the plane when m equals 7, n equals 5. Look, if we find max all regions, how many unbounded regions are there? Here 1, here 2, this part here 3, here 4. Okay, so we can calculate all number of regions and at the end we subtract by 4. Okay, it says the figure shows that there are 8 regions when m equals 3, 8 bounded regions here. When m equals 3, n equal to 2. Okay, so here if I want to solve this, it says m is what? M is 7 and n is what? N is 5. Okay, so it means that how many points are there? 7 points on the bottom and 5 points on top. Okay, let's draw in a new page. Okay, let's draw. We have two lines. Let me draw here, here, and it says 7 on the bottom, 5 on top. So 5 on top. On top we have B. Okay, so B1, B2, B3, B4, and B5. Okay, and n as n is 5, and A1 to A7 on the bottom. A1, A2, A3, A4, A5, A6, A7. Okay, now let's draw one by one. At first, as I said, at the end I subtract by 4. I calculate all regions. If I subtract by 4, as I said here, then we will subtract these 4 unbounded regions. Okay, so I subtract by 4 at the end, then plus. First, how many regions are there? 1, 2, 3. Okay, let's draw first line. I want to draw lines one by one. So here, how many regions it creates? Because it doesn't have any intersection inside, so we said 1 plus intersections. Okay, so it adds 1. Now, if we draw next one, it adds 1. So how many ones are there? A1 to A7, 7. So we have 7 ones. Okay, and let's see. Here that we've drawn 7 lines, we have 6 regions here, 7, 8, 9, 10. And as you can see, 7 plus 3 is 10, so it is correct. Now, let's draw the next lines by another line. Okay, another color. B1 to A1. How many intersections are there? Look, if I draw all things like this, we draw this one, we draw this one. This white line intersects how many points? How many lines it intersects? How many intersections? Look, B1 to A2, it intersects inside. A2, A3 to A7. So A2 to A7 is 6. 6 intersections, so 6 plus 1. Okay. Now, can you tell me second line intersect how many? As you can see, it's A3 to A7. 5. Okay. 5 intersections, so 5 plus 1 regions. The next one is 4 plus 1. And up to last one, if you connect to 7, it doesn't intersect any line inside that, so it will be 0 plus. Okay. Now, next step. We draw B3. If we connect B3, let's see how many intersections are there. A2 to A7 is 6 for green lines. So it will be what? Okay, it intersects for green lines 6 regions. For white lines, also 6 regions. Okay, it connects A2 to A7 to B1, B2. So it will be what? It will be 2 times 6 intersections plus 1. If I consider next line here, it intersects 2 times 5 plus 1. Okay, and plus the last one is 2 times 0. If you connect this, plus 1. Okay, also if you draw this, it will be 2 times 1 plus 1. Now we've considered it was for what? It was for B1, the effect here. It was for B2, it was for B3. So if we connect B4, if we consider B4, it will be similarly, can you say, 3 times 6 plus 1 up to 3 times 0 plus 1. It is effect of B4. And what's the effect of B5? Let me erase this one. B3. The effect of B5 is 4 times 6 plus 1 plus 2, 4 times 0 plus 1. Now, let's calculate. And then I will tell you also another solution. Okay, solution 1 was this. Here, we have all these ones from this part, 6, 5 to 0. So if I calculate negative 4, 3 plus 1, 10. 3 plus 7, 10. 10 minus 4, 6. Then, for each of them, Now, if we consider ones, how many ones are there for each of them? 7. From B2 to B5 that we have here. B3, B4, B5. So B2 to B5, how many points? 4. 4 times 7. Then plus, we have 6, 5, 4 to 0. Plus 5 plus 4 to 0. Times. Here the coefficient is 1. Here 2 times all of them. Because so it will be 1 plus 2, 2, 4. Okay? Now let's calculate. If we consider 6 to 5, if we use the formula 120 is n times n plus 1 over 2, 6 times 6 plus 1, 7 over 2 is 21. Because it's 3 times 7, 21. If we calculate 1, 2 here, we can write 3 also. If we use formula, it's 4 times 5 over 2, 10, or 4 times 3, 7, plus 2, 9, plus 1, 10. So it will be this. Okay, let's calculate. It will be 6 plus 4 times 7, 28. 28 plus 6, 34. 34 plus 210. So it will be 34 plus 210. And if we add, it will be 244. Okay, it was solution number 1. Let me tell you another solution, but before that, I should ask you a question, because you should know this idea. Suppose there are n, let me tell you, there are n points around this. For example, point 1, point 2 to point n. And we connect all points on the circle to each other. So how many lines? For example, you can say n choose 2 lines. We connect all of them, okay? And then we want to see how many, and we don't have concurrent lines inside the circle, okay? Like previous problem that we said, we don't have concurrent points. How many number of intersections are there? It is so much important. Pause the video and try to find it by yourself. Number of lines equal to what means number of chords or number of line segments. Here it will be n choose 2, okay? I mean, for example, PIPJ. Maybe someone says, okay, n choose 2. Each 2, for example, line inside this create an intersection, but it is not correct because look, this line don't have intersection inside the circle. There are lots of things like that. So it is correct, right, for number of intersections. If you want to calculate number of intersections, the idea is this. You should see that each intersection corresponds to what? What does it mean? You say, okay, it is intersection. So if you consider it is intersection of 2 lines, okay? It is corresponding to how many points around this circle? If we consider that, it will be 1, 2, 3, 4. Okay, so the answer will be 4, choose n. Number of what? Number of intersections, okay? Number of intersections. Now, for solution number 2, let's see. We can do what? We can say that. How many points do we have? 5 points here, 7 points here. It says A5, and B5, and A7. A1, A7, B1 to B5, A1 to A7. So here we say, okay, we have at first how many regions? 3 regions, and at the end we should subtract by 4, like previous problem. Then, when we draw each line, okay, we calculate number of intersections that it creates, okay? So we calculate each intersection once, so number of intersections plus 1. So it will be plus n number of intersections in all, plus, because for each line when we draw, we have plus 1 plus number of lines that we draw. Number of lines is easy, 5 times 7, 35. Okay. Number of intersections. If you want to use same idea like this, each intersection correspond to how many points? 2 points here, 2 points here. So it will be 5 choose 2 times 7 choose 2. Okay. 3 minus 4 is negative 1. So let's calculate this. Negative 1. 5 choose 2 is 5 times 4 over 2. It's 10. 7 choose 2 is what? It's 21. 7 times 6, 20. 42 over 2, 21. Plus 35. Now it will be what? 10 times 21 is 210. It's negative 1 plus 210 plus 35, 245. It will be 244. Okay, it was another solution and another approach for solving this problem. Okay, so as I told you, I wrote some homeworks for you. Let me show you the homeworks for what. We solved this problem of AIME, the level after AMC, and try to do these homeworks 1, 2, 3, 4, 5, 6. If you wanted more homeworks, or wanted to learn new ideas, wanted to solve more problems of this idea in BMO, British Mathematical Olympiad, AMC, AIME, IMO, International Mathematical Olympiad, as I said before, feel free to send message my WhatsApp number in the description and comments. Okay, thanks, bye.